we've got here to look at, got an equation of a line that it says 3x minus 4y equals 12. Okay, I'm telling you that is linear. We'll talk about how we can tell all that later. But that is 3x minus 4y equals 12. What we're going to do here, the good old input-output table with x, y. We've got some missing values in that table. So remember, and that's the first way you learned how to graph a line when you were about 6th and 7th grade, is you made an input-output table, plugged in values for x, got out values for y, and then plotted your points that way. So remembering that this first blank that I have here, that's going to be the order pair 0 something. That's how that goes, right? So this one will be something 0. And this one's going to be something -2, and then our last one will be -6 something. So we're just filling in the blank of what that order pair would make. So number 1, when x is 0, plug a 0 in for the x. Okay, now, I'm going to get into it in a little bit, but those first two where you've got the zeros, those have special names. And we'll get into that here in a little bit, but it's your intercepts. Because if I think about this, if I have a 0 on the x, if I do not go up or down any, that's going to tell me where it would cross that. That's going to be your intercept. So we'll get into that in a little bit more in just a second. 3 times 0 is 0, so I could write 0 minus 4y, or I could just leave it off altogether. So when x is 0, should have gotten a y of -3. So we know that line has to go through the point 0, -3. Okay, now same thing going the other way. This second one, it puts a 0 into the y spot. So we're going to plug a 0 into the y. Be 3x minus 4 times 0 equals 12. So 4 times 0 is 0. So you could write 3x minus 0, which is the same as just 3x. So that's a one-step equation to solve there. When when y is 0, x has to be, oh, very good. All right, now the next two pieces of info that they give me are non-zero numbers, which means that I'm actually going to have another step to the equation to solve. It's not going to be a one-stepper like that. Does everybody have this work here? I'm going to erase that so we can keep it all on one page. Alright, so when I plug the -2 in, it goes in the y, because that's where it is in the table. So 3x minus 4 times -2. So that would start off. Now be careful with how you write this when you do that multiplication, because that's -4 times a -2, which makes that a +8. Still not a difficult equation to solve, but you got another step because it wasn't a 0, it's an 8 now. So what do we do to get rid of that +8? Subtract it. Uh-oh, I must have messed up. I can't have a fraction or a decimal. So my 6 is 4. Did I mess up? Anybody there today? Mm-hmm. Can I have a fraction or a decimal? Is that? Yep. So 1 1/3 is the same as 4/3. If you like to write it as a mixed number, I kept it as an improper fraction. Not as easy to graph when we got to count that. It's hard to split your little boxes on graph paper up into thirds, but still is an option. Alright, the last one we got to plug in -6. So do I plug it in the x or the y? X, very good. Just make sure you plug it in the right spot. So 3 times -6 minus 4y equals 12, -18. Now what will we do first to solve that? Add 18 is exactamundo. So we got -4y equals 30. Oh, we got another fraction on this one. Divide by -4. Let's see, that would be 30 over 4. Take a 2 out, -15 halves, or -7 1/2 if you want a mixed number. Alright, everybody remember how to do all that? Easy stuff. Now, keep those same points up there that we just found, and let's talk about what quadrant each of those would be in. You remember your quadrants on the coordinate system. If I go over 0 and down 3, that's a trick one. Erase this and draw a coordinate for your quadrants. That's hard to say, a coordinate for your quadrants. Alright, if I go right and up, what quadrant am I in? 1, and then they go counterclockwise. So there's 2, there's 3, and there's 4. But these first 2 points are trick ones, because if I go over 0 and down 3, which one of those am I in? Am I in quadrant 3 or quadrant 4? 4. Neither. If you're on the line, you're not in a quadrant. So that one would be in no quadrant. Okay? Same thing with this second one here. If I go over 4 and up 0, I'm not in either one. I'm on the line. So first 2 would be in no quadrants. Alright, but what about number 3 here? 4/3. So that's 1 and 1/3, and then -2. That'd be right there. So it would be in quadrant 4. And then -6, -7.5 would be way down here in quadrant 3. So things to remember about the quadrants. To get into quadrant 1, I have to go right and then up. So I've got to be a positive and a positive. And remember, 0 is neither positive or negative, it's neutral. So that's why a 0 can't land in one of the quadrants. To get in quadrant 2, I got to go left and then up. So I got to be a negative and a positive. To get in quadrant 3, I got to go left and then down. So I've got to be a negative and a negative. And then to get in quadrant 4, I got to go right and then down. So I got to be a positive and a negative. Kind of look like I made little winky faces. Alright, I was hinting to you earlier, everybody got that one? Got what you need there? I was hinting to you earlier about X and Y intercepts, so we're going to go ahead and talk about intercepts. When we are finding intercepts, we're going to let Y equal 0 to find the X intercept. And we're going to let X equal 0 to find the Y intercept. Okay, so what that should make sense to you, because let's say if Y equals 0, let's just say I had the point 3, 0. Okay, if I go over 3 and up or down 0, I'm on the x-axis, so I would be an x-intercept, right? This one says let x equal 0, so what if I had the point 0, 3? I would go over 0 and up 3, and I'm on the y-axis, so I would be a y-intercept. Okay, so make sure you know. If you're plugging whichever one you're trying to find, you're plugging a 0 in for the opposite one. That's how you can say that. When I did this, and we started graphing lines when I used to teach middle school 1,000 years ago, they could graph real good if it was in slope-intercept form. Remember y equals mx plus b, y'all remember that? But if it was in standard form, ax plus by equals c, I tried to get them to graph finding those intercepts, and they never caught on to that. But in my opinion, it's just as easy because you just do zeros. But that was always a struggle with middle school kids for whatever reason. But you are seniors, so it's not 2x minus y equals 4. Let's look at that. 2x minus y equals 4. Directions say to find the intercepts. So we're going to find an x-intercept, and we're going to find a y-intercept. Which one you want to find first?
Y.
Okay, if we find the y, what do we put a 0 in for? An x. Very good. And so you can write this as 2 times 0 minus y equals 4, but I don't even write that when I start working them on my own. All I do, and y'all have seen me do this before, 2 times 0 is 0. So if I'm trying to find the x-intercept, or the y, Austin said the y, I'm trying to find the y-intercept, all you're basically doing is taking the x out. Because 2 times 0 is 0. So 2 times 0, 0, we're just left with negative y equals 4. Now that's almost good to go, but it's got a negative y. How do I undo a negative in front of that y? Divide by negative. So y is negative 4. Okay, so this y-intercept would be 0, negative 4. Right? Okay, so based on what I just showed you now, if I want to find the x-intercept, that's the other one we got left, I'm going to put a 0 in for the y. That just takes the y out. So you just got 2x equals 4. So if 2x, that speaker is buzzy, 2x equals 4, x would be 2. So our x-intercept is 2, 0. Now, I didn't ask you to graph it, but what I was saying earlier, it's super easy. You can draw a line with those 2 points now. So if we go through 2, 0, and 0, negative 4, that's all you need. Connect those two, and that's your line. Easy schmeezy. So if you had, right, got what you need on that one? If you had 4x minus y equals negative 3, and I want you to find the x-intercept and the y-intercept. See if you can do that one on your own. Go.
Is that a negative 3?
Yes, equals, that's ugly, you're right, equals negative 3. That's a little bit better. See if you can get that one knocked out. Find the x and the y-intercept. Everybody got it?
Yes, ma'am.
All right, Austin, which one did you find first?
Y.
So he put a 0 in for the x, so he had negative y equals negative 3. That one's pretty simple. Just divide by negative switches all the signs. So everybody get 0, 3 for your y-intercept? Okay. Ran into a little bit of a dilemma if you're unsure of yourself. Fractions always make it even worse. So you're going to get a fraction or a decimal for your x-intercept. If I put a 0 in for the y, just left you with 4x equals negative 3, which means x is negative 3/4. How'd you do?
Great.
You didn't find x? Is that what you said? Oh, I was about to be worried. Alright, now special kinds of lines. Those are all just normal, everyday diagonal lines that have a slope. What if we saw something that said y equals 3 and we were told to graph that?
Do a horizontal line.
I believe Austin is correct. When
Well,
we have,
That was me. That was right.
thank you Blake, I'm sorry, Blake is correct. When we have no x in our equation, this is a note to always write. My line is always going to be horizontal. Its slope is 0. Okay? Horizontal line has a slope of 0. If I have no, this is coming next, if I have no y in my equation, the line is always going to be vertical. What kind of slope does a vertical line have? You may remember that?
Undefined.
Undefined is right. Good job, Blake. Okay. Alright, so y equals 3. Y is up and down. So you would go up to 3 since it's positive, and it would just be a horizontal line through that. That would be it. I'll write that closer on there because I'm going to do the next one on that same graph. Okay, so if I gave you x plus 2 equals 0. Okay, new line down here. X plus 2 equals 0. First thing that you would have to notice is that it only has one variable. I don't see a y in there, do you? So since there's no y, I know it's going to be vertical, but it's not solved for x yet. You need to go ahead and solve it for x. So what would we do to solve this for x? Kids, subtract your 2. So I would go left, since it's negative, I would go left 2, and then I would be a vertical line through that point. That would be your x equals negative 2. Alright, now doing special types of lines here. We did a horizontal and a vertical. We've already done ones that have a slope that are diagonal, but there's a special one that we need to look at here. Everybody got that? Okay, this one says 3x minus y equals 0. The two that we did previously when we found the intercepts, it was not equal to 0. This is going to add us a new dilemma on this. We're still going to, the direction set a graph, okay? And when we graph, when something's in standard form, the easiest thing to do, the easiest way to graph it is by finding the intercepts. But on this one, that's going to be a problem. So I'm going to stick with Austin and find the y-intercept first. So he's going to plug a 0 in for the x, which gives you negative y equals 0. You divide that thing by negative 1. You can't change the sign of 0, so it's just going to be 0. Okay, so we got a y-intercept at 0, 0. Right there. Y'all know what's going to happen yet? Y'all see the dilemma? When I go to find the x-intercept and I plug a 0 in for the y, 3x equals 0. 0 divided by 3 is 0. So I have an x-intercept at 0, 0. Okay, anytime you're in standard form and it's equal to 0, that's going to happen. So I don't know enough to graph that line. I can't graph a line through one point because it could go there or it could go there. So what you've got to do now is pick another point in anywhere. Okay, so you could say, I want to see what happens when x is 1, or I want to see what happens when y is 5, like we did on that table in the beginning. You just got to pick some other point to plug in. The book suggests that you look at your x and your y coefficients. We got a 3 and a negative 1, and you choose a multiple of that. It's not completely necessary, but that way you'll always have whole numbers. So if I look at 3 and 1, my multiples of that are 3. Now, if I plug the 3 in for the x, I'm going to be dealing with a 9, which is a little bit on up there, a little bit more difficult to graph. But if I plug a 3 in for the y, that's going to keep my number low. So that's what I'm going to do. Okay, but for your purposes, you need to know that once you get that 0, 0, you just need to pick any number and plug it in for one of them and solve. Be careful. If I plug that 3 in for the y, I got to make sure I put it in the right spot. Okay, so that gives me 3x minus 3 equals 0. Here's what I was talking about. To get a small number, you would add that 3. 3x is 3. So x is 1, right? So I would go right 1 and up 3. And there would be the line. That wasn't very good. Let me try again. Let me delete that one and try again. Yes. You can pick any x or y that you want. It's better. No, it's still not perfect, but better. There was a teacher at another school that I was at, and she would say that when you miss the points like that, you just make them bigger.
That's what I do.
Now you can't tell. Alright, I haven't spent the second bullet up there. I haven't spent a whole lot of time on plotting order pairs other than we found those intercepts and graphed them. You started plotting order pairs in about the 5th or 6th grade. So we ought to be good on X's over and Y's up and down, right? We need to do that some more. I wouldn't think so, but okay, so the next thing that we need to look at is our midpoint formula. This is an Algebra 1 and Geometry review. To find the midpoint, you're going to add your X's and half them. Add your Y's and half them. Midpoint gets half because it's halfway between them. So if I had line segment PQ, where P was at negative, or P was at positive 4, negative 3, and Q is at 6, negative 1, and I asked you to find the midpoint. Alright, I want to get us an idea before we find it of where we think it might be, so we'll know if we screw up or not. If I go right 4 and down 3, I'll be roundabout in that area. If I go right 6, this is a short segment, and down 1, it's going to be roundabout in that area. So midway between there, it's going to be somewhere in here. So 1, 2, 3, 4, negative 4, negative 5-ish. And it's got to be negative 2, I would think, right? Let's go ahead and find it now and make sure. My X's, and this is baby stuff here, but that's X1 and Y1. X2 and Y2. I just put ones first in the first one and 2 second in the second one. So I would have 4 plus 6 divided by 2. And negative 3 plus negative 1 divided by 2. 4 plus 6 is 10. Half of that is 5. Hey, that's what we said it'd be close to, isn't it? Negative 3 plus negative 1 is negative 4. Divided by 2 is negative 2. So that's what we figured it would be. But now we know for sure. We did the algebra and found it out for sure. Now when they make those more difficult is when they give you the end and ask, or give you the midpoint and ask you to find an end. And I was looking to see if they do that in this lesson, and it doesn't look like they do that yet. I think we ought to go ahead and do it anyway. Let's say I got a segment that has an end at negative 8, 4. That is one end of my segment. A midpoint of negative 5, negative 1. What's the other end of points? Okay, now we could look at the graph and figure out the way we did the last time. But if I know, hey, I don't know. Yeah, I didn't buzz in there. I know if I look at just the x's, I have to do negative 8 plus some x, half that, and it's got to equal negative 5. Right? Everybody see what we did? Because my negative 5 is in the midpoint spot. So if this is being divided by 2, how can I undo that division of 2? Okay, good job. Negative 8 plus x equals negative 10. So then what would I do to figure my x out? Attaboy. So x is negative 2. So I know that this one had to be negative 2 something. Now I'm going to do the same thing with my y's. My midpoint of the y is negative 1. So my end, I got to have 4 plus some y. I gotta half that, and it's gotta equal -1. It's being divided by 2, so we would multiply by 2. Then what would our last step be to solve for y? So our y would be -6. So there would be the other end. So you still had to use the midpoint formula. You just were working backwards a little bit. Alright, last few that we're going to do, you're going to do them by yourself. This first one says 5x plus 2y equals 10. Going to graph that. Then you're going to look at x minus 2y equals -4. You're going to graph that. And then one more, x plus 5y equals 0. Graph that. Okay? How did we start when we graphed these earlier? What was it I said that we did? Found the intercepts. So that's how you're starting, by finding the intercepts. It's a positive. Oh, what you're on the x. So if you're doing the x, that would be -8. Because this is an xy. If you're finding the y, you put a y there though. That's why you're confusing me. But yeah, it didn't. That's right. Yes. Alright, what'd you get for the intercepts on number 1? 5x plus 2y equals 10. Y equals 5, so I've got over 0 and up 5. What else?
Two.
X is 2, so over 2 and up 0. So everybody got?
Yes.
Got something that's similar to that for the first one?
Correct.
Good deal. What'd you get for intercepts on number 2?
Y equals 2.
And x equals -4.
Alright, everybody okay on that one? Not very difficult. Okay, then I gave you the 0 one on the last one, so you're going to get 0, 0 for both of them, which means you had to find another point.
Oh, yeah.
Okay? Shelby, what other point did you find? Shelby, what other point did you find? Still doing it? Katie, what other point did you find?
Well, I didn't.
I got it.
So
Tell me, Blake.
For x will be 1 and your output for y will be 1/5.
That's a pretty good one. What Blake did there, he plugged a 1 in for x, so that gives you 1 plus 5y equals 0. I think it'll be negative 1/5, though, won't it, Blake? That gives 5y
Yes, it will
equals
be.
negative 1, which means y is negative 1/5. Okay, so he would go right 1 and down 1/5, which is down almost nothing, right? So you would have a line not very steep going through those 2 points. Now, what if somebody else had gotten another point? What if somebody plugged in a 3? Is that all right? Yeah, you
It's
can
still
plug
gonna
in.
go on.
Good, it still would fall on the same line, so you could plug in any points you wanted on that. Okay? Everybody all right on that?
Yes, ma'am.
Pretty easy stuff. I was looking to see where it goes from here. And tomorrow's stuff is just all about slope. So be all things slope tomorrow, which I'll be good at again.
And that's part 2.